Hello everyone, today we are going to solve some practice problems for RNS configuration. In this molecule we have a chiral center and these chiral center is attached to four groups: OH, methyl and ethyl group and hydrogen. Now oxygen, the first atom attached to the chiral carbon, having higher atomic number, so we'll give first priority to that. Now in between these two carbon, this one is the methyl group with 3 hydrogen and then ethyl group, so 2 hydrogen on the first carbon, then we have a carbon, so this will ethyl group will get the second priority and then the methyl group third priority and hydrogen will have the fourth priority. Now the lowest priority group is on the back, so the problem is easy. We have to just see the sequence of the rest of the group, and as you can see the sequence is anti-clockwise 1, 2 and 3. So this molecule is having a configuration S. Now let's see this problem. In this problem we have a chiral carbon and this chiral carbon is attached to the chloro group, and then the two groups in the plane, the first atom is carbon, and when we have to give the priority, chlorine will get the first priority because of its atomic number. And the rest of the two groups, if you look into the left hand side, the carbon is attached to 2 hydrogen and 1 carbon, whereas the group on the right hand side is having 1 hydrogen and 2 carbon. So the right side group will get the second priority and the left side ethyl group will get third priority and hydrogen fourth priority. Now the lowest priority group is in the back, so now it's simple that we have to check the sequence of the group. The sequence is going clockwise. That means this molecule is having configuration R. Now let's see this problem. Here we have a chiral carbon and this carbon is attached to carbonyl carbon, methyl carbon and ethyl carbon. The carbonyl carbon is having 2 oxygens next to the first carbon attached to the chiral carbon, so this will get the first priority. Ethyl will get the second priority because it is having 1 more carbon next, and methyl will get the third priority and hydrogen will get the fourth priority. Now in this case lowest priority group is in the front, so in this situation we have to follow a trick. I have explained why we are using this trick in my previous video, so please go through that. First we have to assign the configuration. So if I look at the sequence, we have 1, 2 and 4, so that is going anti-clockwise. So basically at present is a S configuration, but lowest priority group is in front, so we have to reverse this configuration. So the right configuration for this molecule is R configuration. Now let's see this example where we have a lowest priority group in plane. So this is a chiral carbon which is attached to the OH group, methyl group, ethyl group and hydrogen. Oxygen will get the first priority because of its higher atomic numbers, so 1 for OH group, second for ethyl group, third for methyl group and 4 for hydrogen. But here you can see that lowest priority group is in plane, so now we have to go with the swap method. Whenever we swap the groups, then you have to remember the configuration what we are getting is the reverse of the original configuration. So after swapping, you see that number 4 is now on the back and number 3 is in plane. That means that now you have hydrogen on the back and CH3 in plane. And now if I see the sequence of the groups, we have 1, 2 and 3, 4 is on the back. So basically this is going clockwise. So this is at the moment is R configuration, but this configuration we are getting after swapping it. So that means the configuration what you are getting after swapping is R, but it is the reverse of the original configuration. So the original configuration will be S configuration for this molecule. Here we have a chiral carbon, and the chiral carbon is attached to NH2 group with nitrogen, carboxyl group through carbon, and methylbenzene through carbon, and hydrogen is on the back. So if we give the priority, nitrogen will get the first priority. So NH2 group will be having first priority, carbon with the carbonyl and oxygen group second priority, and CH2 group with benzene getting third priority, and fourth priority will go to hydrogen. Now hydrogen is on the back, so the problem is quite simple. We have to just look the sequence of 1, 2 and 3, and if we look at the sequence, it's moving in a anti-clockwise direction, so this molecule is having S configuration. This molecule is enantiomer of the last molecule, and here you can see that NH2 group is in the back. That means hydrogen will be in the front. And if we assign the priority, then NH2 will get the first priority based on its atomic number with the nitrogen, and carboxyl group will get the second priority, and benzyl group CH2 and benzene group will get third priority, and hydrogen will get the fourth priority. Now the least priority group is in the front, so we have to follow the trick. First we have to assign the configuration, keeping 1 in the back, so the sequence is moving like 2, 3 and 4. So as you can see, it is anti-clockwise, so we can write it's S, but we know that lowest priority group is in the front, so we have to follow the trick, reverse it, and its final configuration will be R configuration. So this molecule is having R configuration. Here we have a molecule where there is a CH3 group, and this CH3 is on the back. That means hydrogen is in the front, and the rest two groups, those are in the plane, is attached through carbon. Now if we want to give the priority to the groups, then carbon having 2 OH groups will get the first priority, and benzene group will get the second priority. CH3 will get third priority, and hydrogen will get the fourth priority. Because hydrogen is in front, least priority group is in the front, so we have to follow the trick. First we have to assign the configuration by looking at the sequence, and if we look at the sequence 1, 2 and 4, as you can see that the sequence is clockwise, so the configuration is R. But because least priority group is in the front, so we have to reverse this configuration, and the right configuration for this molecule is S. This molecule is a drug thalidomide, and if you look here, we have a chiral carbon attached to nitrogen through the wedge bond. That means this group is in the front, and we have two groups in plane and hydrogen is in back. So if we give the priority, nitrogen will get the first priority, so we will write here 1 for this group. Then we have carbon, which is having oxygen and then nitrogen, so this will get the second priority, and this carbon group will get the third priority, and hydrogen with 4 priority. Because hydrogen is on the back, least priority group is in the back, so this problem is simple, just to have to look at the sequence. If I look at the sequence 1, 2, 3, so this is your clockwise, so it's the R configuration. So we have done some problems on R and S configuration. Keep practicing and see you in next video.